Okay, so I thought we'd do a question out of the SciPAD just so that you've got one maybe that you can work through with me. So I've chosen question 3 on page 54 of SciPAD, and if you look at the page here, I'm using the letter B for brother, S for sister, and D for dad. And I've drawn a diagram of the situation here. So I've got the sister sitting on the right hand side, brother sitting on the left hand side, and dad who's applying an upward force, okay, which we don't know the size of, and I think the question is actually asking us to work that out. Find the force applied by the father to achieve equilibrium. Fully label the diagram including clockwise and anti-clockwise torque. So obviously sister here, she's got a mass of 44 kilograms. So her weight force is going to be 44 times 9.8, which is 431.2 newtons, not rounding anything during the question. And we've got brother on this side applying a weight force down this way, and that is 52 times 9.8, which gives us 509.6 newtons. Sister sits 2.2 meters away from the fulcrum or the pivot point. Brother sits 2.4 meters away on the other side, and dad is applying a force 2.5 meters away from the pivot point. So I've labeled my diagram. Now I'm going to work out where the torques are. So if sister was the only one on the seesaw would come around like this. So she is providing clockwise torque. Brother is, if he was the only one on the seesaw, then the seesaw would come around and down in this direction. So he is providing an anti-clockwise torque. And the tricky one here is dad. So dad, if you notice that dad's force is in the opposite direction to brother and sister. So if dad was the only person there, and if he was applying a force up, then what would happen to the seesaw if dad's pushing up this way, where my finger is? Okay, you can see where the seesaw is going to go because my pen is going in the same direction. So by dad applying an upward force, he's actually applying a clockwise torque. So in equilibrium, it has to be dad's force plus sister's weight force. Okay, that clockwise torque plus this clockwise torque have to equal this anti-clockwise torque. That's in equilibrium. Okay, so let's start doing some calculating now. And as always, I'm going to write, oops, I forgot my sign there. Clockwise torque equals anti-clockwise torque. Okay, so the two things that we need to add together to find the clockwise torque are the force, dad's force, which he's applying 2.5 meters away from the pivot point, plus the torque that sister is providing, which is your 431.2, which is being applied 2.2 meters away from the pivot point. And that equals the torque that brother is providing, which is 509.6 times 2.4 meters away from the pivot point. Okay, so what I'm going to do now is go through and calculate all those. So I've got 2.5 times dad force plus need my calculator to work that out. So my 509.6 times 2.4 is 1223.04. Oh, here I've got that one, 948.64. Okay, so you can work those out on your calculator. You should get the same numbers as me. Okay, and then what I'm going to do, let's put a brain box here, is subtract 948.64 from both sides because it's added here. And I get 2.5 times dad force. And when I do my 1223.04 minus 948.64, I end up with 274.4. And what I'm now going to do is divide by 2.5, and then I'll be able to calculate what dad's force is. And that comes out at 109.76, rounded to two significant figures, 110 newtons upwards. Okay, so dad provides 110 newtons of force upwards to keep that seesaw in equilibrium. Okay, and the reason he has to do that is because sister is lighter than brother. She has less mass, so he has to provide a bit more clockwise torque to keep them all horizontal or in balance or in equilibrium. So I hope that helps, girls.